Okay, here's how I'm going to start off today, not by doing the notes, but by reviewing a little quiz with you right now. Name a figure and its area we've gone over already. Name a figure and its area that we've gone over. Last 2 days. 11 started us off. Good, trapezoid. Also, if you don't want to remember that trapezoid formula, how else did we talk about? What can you break a trapezoid up into? Square and two triangles, or sometimes a rectangle and a triangle. All right. More. I got trapezoid. What else? 9. What else have we covered? Got it. Triangle. Base height times a half. Next up, got more figures here. Here we go. 14. Another figure. Yep. Kite, trapezoid, triangle. Next, 10.
A rhombus is also half of the diagonal times the other diagonal.
Kite, rhombus, same formula. Looking for another biggie here. We did day 1. 19. Parallelogram, base times height. Questions on those? Today, circle. Circle. It's on your formula sheet, I believe, if you ever forget it. And we also went over it on day 1, so look back if you need to. Area of a circle. 17. Pi r squared, r for radius length. Yep. Am I really concerned about that? Absolutely not. Not in this class. I'm going to show you a new part of a circle. Everyone go ahead, draw your own circle. And here's what I need inside. 2 radii drawn. 2 radii drawn. So please go ahead, draw your own circle, top right-hand corner, and draw 2 radii in for me. Do you see the piece that you have formed by your 2 radii and the arc in between the radii? Everyone see this whole section right here? That section, I'll even highlight it on mine, that section right here is called a sector. All right? A sector. It's like a piece of pie, piece of pizza, however you want to refer to it. All right? That's the sector of a circle. Please do not confuse it with this. You don't have to draw this, just take a look. Please do not confuse it with this. That's not a sector. Okay, a sector is the entire thing in between the radii. Okay, that is not a sector, something different. All right, not a sector. First half of today, how do I find the area of that? All right, how do I find the area? There's 2 ways, and here we go. I know this is going to you're going to get cranky about this, but oh well, I'll survive. Degrees versus radians. Sometimes this angle could be in degrees. Sometimes this angle could be in radians. And I say this angle, but can you give a more specific name for that angle for me, please? 9, give a more specific name for, what is it? Central angle. It could be in degrees, could be in radians. If it's in degrees, everyone, here's how I find it. Here's how I find the area of this shaded region, this sector. Measure over the arc times 360. Almost anybody challenge here. That's almost what? Measure of the arc over 360. Excuse me. Sounds familiar, right? Almost very, very similar to what formula from the last unit? Arc length. Thank you, Will. Arc length. But instead of multiplying by the circumference, this is part of the what of the circle? It's part of the area. So I'm going to multiply by pi r squared. All right. Instead of the angle being in degrees, maybe it's in radians. Here's the formula you can use for radians. 1/2 r squared, r still for radius, theta. And theta is central angle in radians, if it's given in radians. I want you guys to realize you do not need to memorize both. If you rather just stick with this one, fine. But if they give you in radians, what do you have to do before? Convert it. Okay, you convert it. All right, you do not have to memorize both. You can memorize one, and then if it's in degrees, convert it. If it's in radians, convert it. Right? Okay, first example. These are all old Regents questions I'm showing you right now. Help me out. We had 4 people. 4 people show their work for sector COB. All right. Again, sector COB. Right here, guys. Right here. Sector COB. This whole piece of COB. The whole thing. 4 people. Amy, Beth, Carl, Dex. 2 of them are right. 2 of them are wrong. Can you help me find out the correct ones? Well, before we do that, let's do it correctly as a class. Area of a sector. I see degrees, so I'm going to use the degree one. What is the measure of the arc for sector COB? Measure of the arc. Let's start it off right. 15? 108. So 108 over 360 times pi r squared. I don't have a radius length, so I'm just going to leave it r squared. Okay, who did it right? Who did it wrong? All right, let's look at Amy's. 3 over 10 times pi times bc squared. Is she right or wrong? And if you're going to tell me she's wrong, tell me what part of her formula is wrong. Okay, is she right or wrong? And tell me what part of the formula is wrong. Here you go, 17. She's wrong. Yes, she is wrong. Why? What part of her formula doesn't make sense? Yeah, I should be doing pi radius squared, not pi chord squared. Good job, Max. So she's wrong. What about Beth? What are we looking at for Beth? 17. Go ahead, Max. Is Beth right? Yes, because now, what's OC? That's a radius. 108 divided by 360 times pi r squared. Got it. Good job, Beth. What about Carl? 11. Carl, right or wrong? Why? Do 108 divided by 360 in your calculator. And then turn it back into a fraction and let me know what it is reduced. Math, fraction. Hit the math button, left-hand side. 108 over 360 is the same as? Okay, so they're the same, right? And she's taken half of AB. What's AB in this diagram? And what's half a diameter? So she's squaring he's squaring the radius, right? Okay. He's good. Why is Dex wrong then? Obviously he's wrong, but why? What's wrong with Dex's formula? 15? Well, what's he squaring? Not the radius, but he's squaring the diameter. Yeah. Okay, he's squaring the diameter. You should be squaring the radius. All right, so Beth, Carl, here you go. Questions? Okay, next up. Area of the sector. Radius is 8. Central angle, 60. Okay, let's see what this looks like. You guys can just plug in if you want. I just like a diagram here. So 8 inches, 60 degrees. What's your sector length? Sector area. All right, I'm working with degrees, so I'll stay with that degrees formula I first gave you. What is the measure of the arc? Here you go, 10, measure of the arc. Okay, do we know what formula we're using here? Measure of the arc over I'm asking for the measure of the arc. Okay, what type of angle is this? Okay, and then from last unit, what's the central angle equal to? Okay, here we go, one last time. Central angle is equal to its arc measure. That's an inscribed angle, Luke. That is an inscribed angle. Central angle is equal to its arc measure. 60 over 360. Everybody good there? We good? All right, times 9.
Times pi 8 squared.
8 squared, okay. So 60 over 360. Everyone notice your choices. What are they all in terms of? Pi, so that tells me I'm not going to touch the pi here, but I am going to do 60 over 360 times 64. And obviously leave it as a fraction if you can, because all the multiple choices are as a fraction. And as a fraction, what are you leaving it as? Here we go, 10, what are we leaving it as? Okay. Okay, you ready? In your calculator, 60 divided by 360. And then I'm multiplying that by 64, keeping the pi out of there. And I get this decimal on my calculator. And then you change that right back into a fraction. Okay. 32 pi over 3. Questions, comments, any concerns there? Yep, Sean? Okay, here we go. Here's a little calculator session now. All right, calculator session. 60 divided by 360 times 64. I'm keeping the pi out of it because it's got to be in terms of pi. I get that decimal. Math, you have a math button on the left-hand side. Number 1 is change it to a fraction. 32 over 3. Now, I've been preaching this all year long. If you use your fraction template, 60 over 360 times 64, it'll already leave it as a fraction for you. Okay? That's why I've been preaching to you guys to please use that template all year long, because you don't have to worry, it'll already convert it into a fraction. If you need a decimal then, yeah, okay, then go to math and hit number 2 now, change it into a decimal. And I will change it back to a decimal for you. What's the measure of angle AOC? What's the 12 pi? 16, what's the 12 pi? That's the area of the sector. So 12 pi is equal to, here we go, measure of the arc. Do I know the central angle or the measure of the arc? Nope. So I'm just going to pop the x there over 360 times, what's the rest of the formula? 12, what's the rest of the formula? What is it? Times. What is x again in the formula? Arc measure. Why is that also going to be my final answer? Angle AOC is the same as arc AC. So that will be my final answer. All right, let's clean this up here. Whoo, boy. I'll make it easy on you. What do you have on left and right side of the equal sign? That's the same. Pi's. No matter when you do it, they're going to cancel each other out. All right, so the pi's will cancel each other out when you divide them eventually. So you're left with 12 equals x over 360 times 36. Your move, not mine here. Your move. Measure of the arc. 17, measure of the arc. Do we want to see how we do that? You can divide by 36. You can multiply by 360, a couple different options at the beginning. Okay, divide by 36 or multiply by 360, it's up to you. But yes, 120 degrees. Okay. Time for two figures smushed together now. Explain to me, what do I have here if I'm going to find the area of the entire patio? Explain to me what I have. 2, what do I have up here? Okay, so I'll find the area of that trapezoid and the area of what else? Half a circle, yep. So area of a half a circle, and add them together to find the total area. Refresh, refresh. What are those area formulas? It's 15, trapezoid. Okay. Plus, what about my circle? 20? Good. Why divided by 2 here? It's a half a circle. So you can either divide it by 2 or you can put the 1/2 in front. It's up to you. Both will be the same. All right, everything is given here. You do not need to do any side business like Pythag or 30, 60, 45, 45. Every single value is given here. Trapezoid, here we go. 3, 1/2 the height, which would be 4. Bases, 7 and 10. Plus 1/2 pi. How about the radius? I guess there is one little side thing you have to do here. Sorry. 9. 5. Yep. Half a 10. Okay, hold on. Take your focus up here, please. Get your focus up here. I know it says round to the nearest 1/10 of a foot, which I'll do in a second. If, though, the direction said leave your answer in terms of pi, does anybody think you can combine these? Do you think I can combine 34 and 12.5 pi to get, let's see, 46.5 pi? No, you cannot combine them. If the directions, and I'm warning you because this is the next one you're going to do on your own, if the directions say leave your answer in terms of pi, this is as far as I can go. I cannot combine these two when the pi is attached to the 12.5. All right, so this would be in terms of pi, but nearest 10th would be, what did we end up with nearest 10th? 17? 73.3 square feet. Okay. Whether you want to do it in your group or on your own, you have the next one. All right, it's a rhombus and 3 half circles, finding the area. A little warning, you are going to need your rhombus properties to help you out here. Okay, so you're going to do area of the rhombus. You know the formula for that, plus the area of 1.5 circles. And you're leaving your answer in terms of pi. Work it with each other if you'd like. Try to do it on your own. I'll do my work up here.
Oh, I see.
Please realize when you find a side of the rhombus, that's a diameter of the circle, not a radius.
I would be that high.
Higher squared and then multiply it by 1.5.
Yeah, that's what I did. Yeah.
Oh, okay.
Yeah.
Now, if they weren't the same circle, then you couldn't do that, right?
Correct. But since it's a, well, if it wasn't a rhombus,
Yeah.
you couldn't do that, or a square. You guys can move on to the next one if you'd like. Move on to the next one if you get 5. If not, call me over. I'll help tell you where we got these values from. And it might be hard to tell on that next one, but that little portion in between B and C is shaded. Okay? That little portion with B and C, that where the leg of the right triangle is, that is shaded there.
You have to find the area of the semicircle, then you find the area of the triangle.
How did I get 63? Because I did 1/2 times 6.5 squared and left the pi out. So 6.5 squared times 1.5. Because there's 1.5 circles in that diagram.
Okay, well, if I just did, if I was just doing one.
Well, there's not, these two cover one full circle, but then you got another half one. So there's actually 3 half circles in that diagram.
Okay, I was doing one semicircle. If I did that.
Okay, but there's 3 of them.
I know.
Okay.
If I did that and then just multiplied it by 3, would that still work?
It should. If you, so you're saying find the area divided by 2.
That's not what I'm saying.
Okay, so please take me back and explain to me what's happening.
I found the area of the rhombus.
Yep.
And then this one circle.
The half circle.
Yes, this half circle.
Okay.
And then I was just going to multiply it by 2 other half circles.
But you got to multiply it by 3 because there's 3 half circles. Yeah, and that should still bring you to 63.375.
Like when you type something like that and you can just type it in regularly, right? You don't have to put parentheses
Nope,
anywhere.
because it's all multiplication. Unless, and that's only if you're putting the 1/2 in your fraction template. Don't do 1 divided by 2 times all that.
I don't know what to do to find this if it's not a semicircle.
What do you mean? This is a semicircle, though. So you can find that area
So subtract
and
that.
subtract out, not add it, but subtract out the area of the triangle.
Okay.
Okay, 1/2 base times height.
No, the base is 10 times.
Well, you can do the whole circle, divide it by 2, or you can do the
Because I divided by 2, sometimes it's different.
Okay, so that this